Dear student, today our topic is Lewis dot electron dot symbols or the Lewis structure. What are these? Actually, sometimes in chemistry we need to write the dots or represent the valence electron of certain elements. So an electron dot symbol or a Lewis structure represents the valence electron as dots that are placed around the symbol of an element. For example, sodium. So the problem is that around the symbol, where should we place it? So see, it could be placed on side of the symbol, for example, either here, or if not here, then you can draw the dot here. On either side, you can draw this. And you can draw on the top of the symbol or at the bottom of the symbol. Means on either side of the symbol, right or left, top and bottom. If you have two electrons, for example, in magnesium has two valence electrons. So you can draw like this one on the top and one on the side, and you can draw one on either side. For example, here, and one top and on one on the right side, or maybe one on the top and one on the left side. Similarly, it can be at the bottom along with the side, or on the other side. It's up to you. And even you can draw like this. One on the top, another on the bottom. You can draw both of them. So these are these different ways. But for drawing the dot structure, you should know the valence electron. And you know, valence electron uh, can be determined either by writing the electronic configuration or directly from the periodic table. If an element belongs to group 1 or 1A, so definitely it has one valence electron. If an element belongs to group 2, then it has two valence electrons. So this is the way how to write the symbols, electron dot symbols for element. Now see for other elements as well. Okay, so see for the other elements, we should follow some rules. These are the two basic rules. If 1 to 4 valence electrons are there, for example, in lithium, one valence electron, so you can draw the dot on either side, top or bottom. If there are two electrons, then you can draw the dots on either sides, both the sides, top or bottom, whatever. And if you have three electrons, then you can draw like this. And if you have four electrons, then all the four electrons around them. So why it happens? Because it can form one bond, it can form two bonds, it can form three bonds, it can form four bonds. But in case of elements where there are more than 4 electrons, for example, 5 to 8. So better to draw one in pair and 3 as single dots. As nitrogen belongs to group 5, oxygen belongs to group 6. So you can draw 4 electrons in 2 pairs and 2 electrons as single dots. In case of fluorine, you can draw like this, and you can understand this dot can either be top, bottom, or right or left side, anywhere. And in neon, there are 8 valence electrons. So all the electrons must be shown in pairs. But why it is written like this? Because in valence electron, when you draw the orbital electronic configuration, so in orbital electronic configuration, for example, in case of nitrogen, you can see 1s2, 2s2, and 2p3. And here in S, there are 2 electrons in s orbital. These are the valence shells, and these 5 are the valence electrons. But in p orbital, there are 3 unpaired electrons. So that's why we adopt this method. In case of oxygen, what happened? The electronic configuration is 2p4. So it means one more electron would be here. So there are 2 pairs and 2 unpaired electrons. Okay. And similarly, for fluorine, its electronic configuration is 1s2, 2s2, and 2p5. So one more electron is paired, whether this or this. Okay. So there are 1, 2, 3 pairs, and one is the unpaired electron, that is the single dot. In case of neon, electronic configuration is 10. Number of electrons are 10, atomic number is 10. So 1s2, 2s2, 2p6. So they are all the paired electrons. So that was the reason that we show the electron dot structure like this. And now there are certain elements in period number 1, hydrogen and helium, period number 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And in period number 3, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So you can see their electron dot symbol. In the same group, they are symbolized similarly, except this helium, because of its properties. Helium is placed in group 8, but it has only 2 electrons, so it has some deviation, but its electron is usually written in pair. And for rest of the element, for whole group, symbol is electron dot symbol is similar. So there is no difference. Now you have a question. Write the electron dot symbol for iodine and selenium. So first write the symbol of iodine. Symbol of iodine is capital I. And C in periodic table, where is it? So we can find it in group 7. So we have to arrange 7 electrons. So 7 electrons could be arranged like this, 3 pairs on any of the side, or either top, bottom, or right side. An electron dot here, or other ways are as well. Electron pairs top, bottom, and left side, and the single electron on the right side. And you can draw the single electron here and the pair here. So you can draw the other representation as well. Selenium, the symbol of selenium is Se. It belongs to period 6 of the elements in periodic table that you can see from the periodic table. So you can draw it like this: a pair of electron on top, a pair of electron on bottom, and 2 pairs of electron on either side. But the better way is to draw the pairs on top and the top and one of the side, and single electrons on one of the side and bottom. Or it is also very accurate that if you draw the pairs here and single electron here. But at a school level, it is also accepted that single electrons on either sides and dots like this. Or it could be like this: lone pairs on these are called the lone pairs, but not here. You just say the electron pair, electrons in pair, and single electrons. These two are very accurate. And these are also correct and accepted. We will see in detail when we are to draw the Lewis structures for certain compounds. Now see the next question. Here electron dot symbols are given and you have to find the groups. So it is very easy. Just find the valence electron in the electron dot structure. So in calcium, there are 2 electron dots. So it belongs to group 2 of the periodic table. So it is 2A. B, GE, 4 electron dots, 4 single dots are there. So as there are 4 valence electrons, so it belongs to group 4A. And this element is germanium. This is the symbol of germanium. Br is the symbol of bromine. It has 7 electrons, 1, 2, 3, 4, 5, 6, and 7. So it belongs to group 7A of the periodic table. And arsenic, 1, 2, 3, 4, 5. So it belongs to group 5A of the periodic table. So from the valence, if you know the group, then you can draw the electron dot structure of the valence electrons. And if you know the valence electron, then you can tell us the group of the element in periodic table.